Prompting is not dead, it became context engineering. In this keynote, we'll explore why the future of artificial intelligence mastery belongs not to those who memorize prompt tricks, but to those who design the information ecosystems that artificial intelligence operates within. This is a research-backed presentation built on 2026 data. Let's begin. This presentation makes 3 core claims. First, prompt tricks are dying. Magic words, jailbreaks, and formula-based prompting are becoming obsolete as models now understand intent directly. Second, discipline stays. Clear goals, structured thinking, and model-specific knowledge remain essential, that never changes. Third, context wins. The real differentiator is designing what artificial intelligence knows, how quality is judged, and how workflows are governed. And the data supports this. 68% of firms now provide prompt engineering as standard training across all roles. The job title disappeared. The skill became universal. To understand where we are, we need to trace the evolution. In 2022 to 2023, it was all about magic words, DAN jailbreaks, personas, temperature tuning. These were genuine workarounds for real model limitations. By 2023 to 2024, structured prompt formulas emerged: role, task, context, output templates. Useful training wheels, but still surface level. Then came workflow design in 2024 to 2025, chaining tools, agents, files, memory, and automation into multi-step pipelines. And now, from 2025 onward, we are in the era of context intelligence, designing the entire information ecosystem. Success now equals the right context, plus constraints, plus human judgment. Many organizations fall into what I call the prompt library trap. They build shared drives full of saved prompts, thinking this creates institutional knowledge. It doesn't. Here's why. First, no context. Saved prompts have no metadata, no record of what model was used, what data was available, what constraints applied. 6 weeks later, nobody knows what the prompt was even for. Second, they go stale fast. Models evolve rapidly. What worked with GPT 3.5 breaks with GPT-5. Untested prompts are unreliable prompts. Third, prompts are not standard operating procedures. Prompting is a live interaction with a probabilistic model, not a deterministic checklist. You don't build a smarter team by saving prompts. You build a smarter team by teaching people how to think with artificial intelligence. This brings us to an original concept I call prompt debt. It's the accumulated cost of maintaining a collection of prompts without knowing which ones still work, why they work, or how they fit into your workflows. Like technical debt in software engineering. It compounds silently until it blocks progress. There's an inverse effort law at play. The more effort you invest in collecting prompts, the less effort you invest in understanding how to actually think with artificial intelligence. Collection is not competence. You have prompt debt if your team has a shared drive full of prompts nobody can explain, if output quality drops after model updates and nobody knows why, if new team members can't tell which prompts are reliable, or if prompts are hoarded as intellectual property instead of building shared understanding. Here is the original framework at the heart of this presentation. The 4C model of artificial intelligence mastery. 4 dimensions that separate beginners from experts. Command. What you ask. Clear goals. Specific instructions. Output format. Beginners learn command. Context. What the artificial intelligence knows. Knowledge files, examples, standards, data. Professionals build context. Criteria. How quality is judged. Rubrics, scoring, evaluation, success metrics. Experts define criteria. And control. How workflows are governed. Security, access, compliance, audit trails. Organizations need control. Beginners learn command. Professionals build context. Experts define criteria. Organizations need control. The first C is command. And the core principle is simple. Clarity beats cleverness. Different models respond differently. Claude 4.x prefers XML tags. Aggressive language like "you must" actually hurts performance. GPT-5 is conversational by default. Telling it to think step by step can hurt because the router already triggers reasoning. Gemini works best with shorter, more direct prompts and few-shot examples placed at the end. But 5 principles work universally across every modern model. State your goal clearly, provide relevant background, Specify the output format, ask for reasoning, and iterate, because the first output is always a draft. As Thomas Weigold noted in 2026, the gap between a careless prompt and a well-engineered context isn't closing, it's widening. The second C is context, and the concept here is context capital. These are reusable assets that improve artificial intelligence output and compound in value over time. There are 6 types of context capital: knowledge files, standards, research, datasets, policies, brand guidelines. The raw material, artificial intelligence needs to work intelligently. Example, banks, past work, benchmarks, reference outputs, before and after comparisons of what good looks like. Decision records, why choices were made, what was rejected, trade-off analyses. This is organizational memory. Evaluation criteria, rubrics, quality standards, scoring frameworks, explicit definitions of good, constraints and rules, compliance requirements, brand voice, safety guardrails, formatting rules, the boundaries, and workflow templates, reusable process patterns, agent configurations, pipeline structures, the architecture of your artificial intelligence operations. There is a critical failure mode in context management called context rot. More context does not equal better context. Chroma Research tested 18 large language models and found that performance degrades as irrelevant context increases. What goes into the context window determines almost everything about what comes out. A curated 10,000 token context with relevant documents outperforms a 100,000 token dump of everything. The implication is clear: be ruthless about context curation, include only what's relevant, structure it logically, update it as conditions change, quality always beats quantity. The third C is criteria, and the central concept is the judgment gap. This is the difference between artificial intelligence output and professional-grade output. It has 3 dimensions: accuracy, fact-checking, source validation, hallucination detection. Is what the artificial intelligence said actually true? Quality, tone fit, audience alignment, strategic relevance. Is this the right output for this moment? And decision, actionability, risk assessment, and downstream impact. Can you actually act on this? The most important principle in this entire presentation: artificial intelligence can generate. Only humans can judge. Human judgment is the non-negotiable final filter. The fourth C is control, and the data here is alarming. 73% of production artificial intelligence deployments have prompt injection weaknesses, according to Cisco 2026 and the Open Web Application Security Project's Top 10 Large Language Model Vulnerabilities list. 52% of organizations have no formal artificial intelligence use policy, per KPMG 2025, and only 12% have formal artificial intelligence security testing programs, according to Gartner 2025. Control means input validation and sanitization, sandbox tool access for artificial intelligence agents, human-in-the-loop checkpoints for sensitive actions, output filtering and safety guardrails, audit trails for artificial intelligence-assisted decisions, access control and data governance, regular security testing and red teaming, and compliance documentation and reporting. Governance is not optional, it is the foundation. Let's see the 4C model in action. For research and synthesis workflows. Step 1. Command. Upload your sources and specify the research question clearly. Step 2. Context. Extract findings, disagreements, and gaps across your sources. Step 3. Criteria. Synthesize with citations and challenge for counter-arguments. Step 4. Control. Validate all claims and synthesize with confidence levels. Then, human review. Critical warning: never trust artificial intelligence-generated citations. Artificial intelligence models confidently invent statistics, quotes, and references. Always verify against original sources. The key technique here is to provide the evidence and let the artificial intelligence analyze it. Don't ask the artificial intelligence to know things, give it documents, data, and sources to work with. The second workflow example is presentation creation. Step 1. Define, clarify your audience, goal, time limit, and desired outcome before touching the artificial intelligence. Step 2. Provide, give it your source material, reports, data, and strategy documents. Step 3. Outline, request the narrative arc first. Approve the structure before generating any content. Step 4. Generate, slide content with speaker notes and key messages. Then iterate. Always ask for the outline first. Approving structure before content saves hours of rework. And remember, the artificial intelligence doesn't know your audience's politics or what resonates emotionally. That judgment is yours alone. The ultimate application of the 4C model is building your personal artificial intelligence operating system. 3 components. First, reusable workflows. 4C-based processes for research, presentations, content, decisions, and analysis. Each iteration makes them faster and better. Second, context assets, knowledge files, examples, decision records, criteria, constraints, and templates. A growing library that improves every interaction. Third, evaluation criteria, personal rubrics for what good looks like, refined through practice and feedback. Your quality standards, evolving over time. This is the opposite of prompt debt. This is context wealth, compound returns on every investment you make in your artificial intelligence practice. We close with the master framework. Stop memorizing tricks, start designing systems. Here is the Master 4C prompt, a universal template for any task. Command, your goal is to fill in the blank. Context, here is the background, source material, data, examples, and constraints you must use. Fill in the blank. Criteria, your output will be judged on accuracy, relevance, usefulness, tone, and risk awareness. Specify your quality standards. Control, format the output as a fill in the blank. Follow these constraints. Fill in the blank. And if information is missing or unsupported, state insufficient information. Fill in the blanks. Use this for any task. Adapt the depth to match the complexity. Prompting is not dead. It became context engineering. Thank you.